Hello, how are you doing? I hope everyone is doing great. And today we are going to do some continuation with the topic fraction. So now, what does fraction mean? If some of you have not gone to the earlier video, I recommend, but just doing a recap, what does fraction mean? So the English meaning of fraction is basically part of something. Part of something. So for example, we say that this quantity is fraction of that, so we mean a part of something. That's as per English. But when we want to talk about mathematics, so let's say we have this figure over here and I'm going to divide it into exactly half. So I'll say that it's been divided into exactly two halves. One is above and the below is also exactly divided into the same part. So if I want to take, let's say, this part, the shaded portion, so I'll say that this is one part out of two equal parts. Yeah, one part out of two equal parts. Now, how do I want to represent one part out of two equal parts? Is probably that the selected portion I'll put at top, that is 1, and the total number of portions I'll put at bottom, this is 2, and this is also known as, we know, 1 half. Similarly, when I divide into 4 equal parts, so it will be, let's say, the shaded portion, if I remove this and I just want this shaded portion over here, so what I'll say, this is 1 out of 4, and how this can be written is 1 by 4. Now this is something very basic of fraction, and one thing which might be essential to consider at this point, that what if we have another figure, and let's draw that figure and try to understand. Let's say I draw the figure and we'll try to analyze what happens. The figure might be something like this, yeah, and I'll just take some very small portion of it like this, yeah. I'm taking some very small portion. So will this be part of fraction over here? Will this small portion will be part of fraction? Now, yes, as per the English language which we discussed, it's part of something. So if this is whole, this is whole, so obviously the red portion is part of this whole, but will it be fraction or not? So what we want to understand in fraction is when we divide equally. For example, if I wanted to divide it, what are the ways I can divide equally? So have you ever taken a sandwich? I guess yes, you might have taken a sandwich. So one way of cutting a sandwich would be that you will cut it like this. So that's, we say, equal division. Yeah, that's one of the way. The other way could be that probably I want to cut it in a slant manner like this, and that as well will be equal division. So in fraction, the thing to consider is that when you're taking part of something, it should be equally divided. It should be equally divided. And if suppose you feel it is not equally divided, so we want to specify and mention that the shaded portion is not fraction. And why it's not fraction? Because probably it's not divided in an equal fashion. Right, now we are done with the basics, and we can now continue with this proper and improper and mixed fraction. Now I'm sure last time we discussed what are proper, what are improper. Just a little recap, that the proper fractions, let's say, might be of the type, let's say, 1 out of 2, or 2 out of 3, or let's say 5 out of 7. Now what makes them proper is, technically we are being taught in schools, we know that if above is lesser than denominator, same over here, above is lesser than denominator, same if above is lesser than denominator, the above part is called numerator. If numerator is lesser than denominator, we are being taught that it's called proper fraction. It's called proper fraction. But if we have gone to the earlier video, we understand that the definition of proper is something different. So what the definition of proper is, that let's say I have this cake with me. Yeah, I have this cake with me. So when I'm trying to take a little bit of the portion, it can be either like this, or I'm taking a cake, I'm taking, let's say, this portion, but I'm still leaving this, or I'm taking a cake again, and let's say leaving this, I'm having all of it, yeah, but still I'm leaving this small portion, which is in white. So whenever the value in a fraction is less than 1, for example, over here, this value is less than 1, this value is less than 1, and this value is also less than 1 whole, if we are considering this as whole. So in proper fraction, whenever the values are less than 1, then they are considered as proper. On the contrary, if you add something to the whole, let's see some different examples. The different examples could be of improper fraction could be, if I say a whole, if I take a whole and I'm shading so that I'm emphasizing that I'm taking the whole, and I'm adding, let's say, half of another part. So what total it makes is 1 plus 1 by 2, and obviously 1 plus 1 by 2 means the value is going to come greater than 1. The value is going to be greater than 1. So in improper fractions, we say that a fraction will be improper, and considering the cake story, I told that I had all of my cake which was for me, but I did also have another part of cake which was though very small, but it wasn't meant for me. So the very act of me getting greedy and having something more than what I really wanted was improper. Yeah, so improper fractions might have some examples. Let's say we have, I'll make some space over here. So they might have some examples considering the technique that I'll simply keep the numerator as big. Yeah, so 5 by 4. And how do you want to check it? That you may want to divide 5 by 4. 4 ones are 4. Some remainder, you'll put some point and 0. 4 twos are 8. Obviously point and 0, and 4 fives are 20. So 1.25, if you want to consider on the number line, over here being a 0 and being a 1 over here and being a 2 over here, if I have, let's divide it equally. So if I get this as 1.5, this is 0.5, 1.25, let's say, will come somewhere over here, and obviously this value over here is greater than what we say 1. So improper fractions will be always greater than 1. Why don't you try to give some examples of proper fraction and improper, and in the meanwhile I'll just clear this board. Yeah, alright, and so now we'll come back and understand what are mixed fractions. And we do have an example where suppose we are going to make a whole like this. So I have this one whole, and now I'm going to add something to it. So let's say I'm going to add 1/4 of this. So if this is 1/4 and if this is one whole, and considering that both of them are having same sizes, yeah, so I'm taking whole part out of it and I'm taking 1/4 out of it. So what if I'm going to add both of them? What if I'm going to add both of them? Essentially, I will get something like 1/4. Now, what is 1/4? 1 on the left hand side represents whole part, and the right hand side 1/4 essentially represents my fraction part. Now when I say the fraction part, exactly what kind of fraction is it? You can call it simple fraction, or as you can see, it's a proper fraction. It's a proper fraction. Now, a combination of, you can also think it this way, a combination of whole part and proper fraction leads to something called mixed fraction. Now, what happens when we try to convert this mixed fraction into the form that there is a numerator and there is a denominator? So there is a way that I'll write this mixed fraction over here, which is 1 by 4, and let's try to understand what I can write 1 in terms of 1 by 4. Now, what I'm trying to think is that what if I divide this whole part into four equal parts, and slowly, let's take, it's a pizza which I have ordered, and this is a whole pizza, and obviously it's for me. So slowly I have one part. So how much did I eat? 1 out of 4. Then I ate another part, which is 1 out of 4. Then I take another part, which is 1 out of 4. And then I take the last one. Why? Because the pizza was meant for me. So I take another part, 1 out of 4. So essentially, the whole I have eaten by taking 1 by 4, 1 by 4, 1 by 4. So when 4 times I have taken them, so probably I can write that it is how much? It is 4 out of 4. So this I can write like this, 4 out of 4, and this fraction part is 1 by 4. Now when I add both of them, so I get to keep these, the like fraction part, as we know, when we have like fraction, like we have common denominators as same. So in like fractions, when we have same denominators, we take it as ones. So we take them as common, like 4, and the above part we just simply add. So 4 plus 1 gives me 5, and I get 5 out of 4. Now this 5 out of 4, as we discussed a little bit earlier, this is nothing but a value greater than 1. The way to check is that 5 is greater than 4. And what kind of fraction is it? Yes, in these kind of scenarios, when above is greater than below, the value is greater than 1, we mention these are improper fractions. These are improper fraction. Now this 5 by 4 is nothing but equal to 1 by 4, and why? Because we have given its conversion over here. That's why mixed fraction when converted will give improper fractions, So now you understand, regarding anything when you have mixed feelings, that is improper. So to do some work properly, don't have mixed feelings, sit, relax, have some clarity, and then your work will be proper. Now I'll just try to rub this over here and try to do some conversions, that how can we convert one form to another. Now let's say we have a fraction over here, we have 5 by 4. Let's say we want to do the opposite. Yeah, I want to convert 5 by 4 from improper to our mixed part. So I write my improper fraction, which is given as 5 by 4. So the technique to do over here is we divide it this way. The above part you keep inside, the below part you keep outside. So you just divide, 4 ones are 4, you get the remainder as 1, and finally to write in mixed fraction you should have this form. The whole part will come over here, and let me just make some space as well. So I'll just rub this. Now I got one part over here to get in mixed fraction, the other part comes above, and this last part which comes below, and there is a division sign, and this must be written as Q R by D. Q being as a quotient, which is over here. So my quotient comes as 1, r being as remainder, which is this, so it comes as 1, and d being as a divisor, that is the number which divides. So my d is over here 4, and I'm sure you know the number which is being divided, it's called the dividend. It's called the dividend. So whenever you want to convert, we write in form q r by d. Conversion from improper to mix, you can do this way. And now let's go to the next part of the chart. Alright, and our next chart represents the equivalent and reduced form. Now what does that mean? If you look carefully over here, the first circle here, if we draw, it represents that we are just taking 1 out of 2, right? And the second, if you look carefully, we are actually dividing them into 4 equal parts, and now they are selecting 2 parts out of them. So when they are selecting 2 parts, so the selected portion, as we said in fraction, will come above. So I have 1 and I have 2. So I write 2 over here and a total of 4. 1, 2, 3, 4. So total portion I write over here. The third chart is, the third picture represents a circle again. So I make a circle again and I divide into, let's say, 8 parts. Now how do I actually divide them into 8 parts? Is that I first divide them like this, half and another half, and now probably I want to divide again this way. So I get equal 4 parts below and equal 4 parts above, so total 8 parts. And what if I just select 4 parts again? So I get 1 part, 2 part, 3 part, 4 parts. So the selected portions, number of portions are 4. I put them above, but what do you think must come below? So what will count as number of portions, total number of portions? So I have 4 portions over here and the remaining 4 portions, so 4 plus 4, 8. So the total portions 8, will put them below. Now what equivalent fractions mean is that are these 3 fractions equal or not? Look at them carefully. Are they equal or not? So yes, we can say that 1 by 2 does not seem equal to 2 by 4 at a first glance, and yes, obviously it does not feel equal to 4 by 8 at a first glance when you look at the numbers. But what if you try to see in terms of the picture? In terms of the picture, we see yes, this seems to be half, and this, even though being divided into 2, seems to be half, and this, even though divided into 4 parts, seem to be half of the whole. But how can I convert this into half is by checking if they have a common factor to divide with. So yes, both 2 and 4 can be divided by 2, and when both of them divide by 2, we get, if I write the answer here, we get 1 by 2, which is same as previous one. And when both 4 and 8 being divided by common factor 4, so I get, if I write below, 4 1s are 4 and 4 2s are 8, it's same as the previous answer. So we can say yes, 1 by 2 is equivalent to 2 by 4 is equivalent to 4 out of 8. Now there's some fractions, as we know, they are not equivalent. So we have this example of 3 by 7 and 5 by 7. So let's create some space and try these fractions, that which of them are actually bigger and which are actually lesser. Now if I write again 3 by 7, so I have 3 by 7 and I have 5 by 7. Now I just try to check that which is greater. Now the common condition of comparison of fractions is that you must have them as like fraction. And when I say like fraction, what we mean is that the denominators must be same. If not, then you will have to make them equal, which we'll discuss in just a couple of minutes. But we are really fortunate that yes, now we have like fraction. Similarly, in life, there are certain good conditions and there are certain bad conditions. So when there are favorable conditions, we must be always thankful to people around us, to our friends, family, and God, if you believe. So over here, we have some like fractions. So we'll take this opportunity to write just 7 ones, as we are taking 7 common from both of them, and above, and this is in case of if you want to add, by the way. And since we are not adding, we are just comparing. So I'm sorry, I'll just compare first that which of them is smaller and which is greater. So we know that both of them are like. Now straight away you can just compare. So we know 3 is lesser, and the sign of lesser than is this way, right? And the other way as well, you could have written that 5 by 7 is greater than 3 out of 7, depending which shifts in which position. Now if you wanted to add, as we were just trying to do, so you need to just put 7 ones over here, and 3 and 5 will just add together, and it will give 3 plus 5 will give 8. But that will only happen when somebody asks you that, okay, what is 3 by 7 plus 5 by 7? And this happens when we have a common denominator. Now I was just wondering that in these cases, 3 by 7 and 5 by 7, we were really fortunate, as we said, that we had common denominator as same. So we can just add the numerators. Now what if we don't have such a condition? So let's try to see, and I'll just make some space again. And you can also tell me which are the examples where we don't have favorable situations. I mean, obviously don't tell me that, you didn't get your birthday cake on time, or you didn't get chocolate, instead of that you got pineapple. Don't tell me that, but probably you want to tell that which are the conditions which were not favorable to you. So now probably I want to take example that I have in my mind right now, that I have 1 by 2 and I have 1 by 3. So one way of this is that we just discussed, that I'll try to make the denominators same, and I'll try to make them as like fraction. So let's deal with them separately, as 2 children fight in the class, and we know what the teacher has to do. Teacher just has to talk to both of them separately. So I'll just separate them, and I'll just do it. I'll put 1 by 2 over here, and I'll put 1 by 3 over here. Now I'll just see, okay, how both of them can come to common ground. So as you fight, we try to come to solution in a common ground. So I see, okay, 2 and 3 must come to a common ground in terms of their LCM. So when you take LCM, 2 comma 3, 2 ones are 2, and you get 3, and 3 ones are 3, and obviously 2 into 3 will make our LCM as 6. So what if I can make it as 6, and this as well 6? So we can come to a common ground. So probably I want to multiply something over here, so that it becomes 6. What do you think I should multiply? Yes, 2 3 is 6. And to make it balance in the numerator as well, I multiply with 3 over here. Now same goes for this. What should I multiply to make it as 6? Yes, I can multiply by 2. So when I multiply by 2, to balance it up, I again multiply by 2 in the numerator, and then probably I want to add them if I really want, or I can subtract them. Now it goes this way, that 2 into 3 is this 6, and 3 into 2 is 6. You add both of them, 1 into 3 is 3, 2 into 1 is 2, and as we know, now they are like fractions. Now you're getting to a solution. Whenever there is a problem, you need to find a solution. So now the solution is here, both have come to a common ground, and now I'll just put it as common factor 6 and add 3 plus 2, 5. But I was just wondering, can we try to do it pictorially? Can we really try to do it pictorially? So I'll just try to do a little experiment just for a minute, and probably I'll just rub this over here and make some space and just write it again into 2 into 2. And now the experiment could be that what if for 1 by 2, I can divide it into 2 parts like this, let's say. I'll divide it this way, right? And what if for 1 by 3, I can divide it this way. Now, assuming that they are of equal sizes, the only number of divisions are different. So I'll say that, okay, this is 1 out of 2, and this is, let's say, 1 out of 3. Now, when we are superimposing them, being equal sizes, when we are taking them one over the another, so what happens? When this superimposes over here, it will make 3 equal divisions. And when this superimposes over here, like I have 2 hands, superimposes like this. So this will superimpose and it will make 2 equal divisions. Now all I need to do is put it into a fraction. The total number of parts are how many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I know the common total number of divisions are 6, which I'll put below. And how many are total out of them? I'll simply count. 1, 2, 3. So I'll write 3 parts. And how many parts from here? 1 part and second part. So I'll write 2. And what do I get? 5 by 6. And is it similar to this? Yes, it's similar to this. And that's it. Thank you. Have a nice day.